Hello, welcome to a channel where everything we discuss problem is solved using very simple, easy, fast, and accurate methods or steps. So we have this problem in chemistry. In the electrolysis of copper 2 tetraoxosulfate 6 aqueous, that's the solution, using platinum electrodes, the reaction at the anode is. So there are keywords I should be looking at for. First of all, I want to use this problem to look at that topic called electrolysis. I know you may be familiar with it, but to point out a few things here. When we talk about electrolysis means the decomposition of a compound when direct current passes through the solution of that compound or the molten compound. So if I'm talking about solution, I should expect 4 ions, 2 cations and 2 anions. But if I'm talking about a molten compound, I will just be talking about 2 ions, 1 anion and 1 cation. That's what's the difference between the solution of a compound, electrolysis of a solution of a compound, and electrolysis of a molten compound. The difference is the absence of water, the molecule of water in a solution, just like here. So I will not just be talking about CuSO4. It will be CuSO4 and H2O, such that I will have to break down this into cation and anion, cation and anion. So if I go ahead to do this, this will be Cu2 plus, and this will be for the anion here. Yes, this will be SO42 minus. Why here I have my H2H, or you say H, what I call H or 2H, and then here is OH. You see, so these are the ions that are present here because of this. But if I'm told that it's molten copper 2 tetraoxosulfate 6, I will just have only CuSO4. This is what I have, just 1 anion and 1 cation. These are the ions that will be present if it's a molten compound. So like I said, that the difference between a molten compound and the solution of a electrolysis of a molten compound and the electrolysis of a solution of that compound is the presence of the water molecule. So having said this, then we are told here that we should look for the reaction at the anode. There are things that you should know about the anode. What are the things I know? I know that the anode is a positive electrode, and it is that electrode through which the electric current enters into the electrolyte. Then we have the cathode as the negative electrode by which the electric current leaves the electrolyte. Now, having said that, another thing I have to also mention is this: to talk about oxidation and reduction. I remember the last class I did, lesson I did, a very quite long, and reduction types of reaction. Yes, I talked about oxidation and reduction extensively there. So here we know that at the anode, what happens at the anode is oxidation, and in this case we should say in the anode, this anode is the positive electrode, so it is positive. You should expect OH and SO4 to migrate to the anode. So at the anode, I have these ions that are present, this and this. These are the ions that will migrate to the anode, while at the cathode, which is the negative electrode, the positive ions Cu2 plus and H plus will both migrate here. But this question is all about the reaction at the anode. And what happens at the anode is oxidation. And we talked about oxidation. Oxidation means loss of electron, increase in oxidation number, and addition of oxygen and removal of hydrogen. So in this case, we'll just be talking about in terms of electron Oxidation in terms of electron, that's what we'll be defining oxidation in terms of. So if we're saying that oxidation means loss of electron, in this case I have two of them, they've migrated there, and we're not told that it's a concentrated solution. Remember that in electrolysis there are three things that determines which of the ions will be discharged. One is the position in the electrochemical series. I've talked about that in a lesson in one of my videos. Then the nature of the electrode, and then the concentration. We've talked about that if the concentration of a particular ion is much and the distance between both of them in the electrochemical series is so small, the effect of position will be cancelled by concentration. We talked about that. Then in nature of electrode, there are types of electrode that you use when you are doing electrolysis, and that will affect the ions that will be discharged. For instance, if we talk about the electrolysis of sodium chloride, NaCl, and then we have platinum. You can see here they are specific. They talk about platinum electrode. If we use platinum electrode in this case, we are talking about sodium chloride, aqueous solution of sodium chloride. So we have H, that's an OH also present here, just like we have this here. So we have this and this migrating, this and this migrating to, they will migrate to the anode. Now, in the case of this, if we are using platinum, and it is concentrated, if it is concentrated and we're using platinum, okay, let's look up. I'm talking about the nature of electrode. Let me forget first of all about the concentration, the factor of nature of electrode. If I'm using platinum, in this case, you know that OH is more OH will be discharged in preference to Cl because of the position in electrochemical series. OH will be discharged in preference to Cl. You understand? If we are using platinum electrode. But if I'm using mercury as my electrode in this very case, because of the affinity that mercury has for sodium, you understand? Mercury has for sodium. If I use mercury here as my cathode, in this case, instead of having like I said, here is OH that will be discharged. OH is discharged, then H will be discharged in preference here. Will be discharged in preference here if I have my platinum as my electrode. But if I'm using mercury as my electrode, whether in both cases for the cathode and the anode, because of the strong affinity that sodium has for mercury, H will not be discharged, which will in turn give birth to hydrogen gas, will not be discharged. Instead, sodium will be discharged there because of that electrode. Likewise, when we talk about electrolysis of copper 2 tetraiodosulfate 6, if I'm using copper as my electrode, the product at the anode will not be the same. It will never be the same. So there are three factors that affect the discharge: position in electrochemical series, 2, concentration, and 3, the nature of electrodes. There are a few exceptions. I've just given you the 2 exceptions that when in terms of nature of the nature of electrode, there are 2 exceptions there in that rule, you understand? So those exceptions to the rule, you should know them to the tip of your finger, you understand? So that every other one follows this path, and these are exceptions. Those few exceptions are worthy of note, so that whenever you are asked, you understand, you can be very fast in doing what? In giving the answer, because examination is all about time. Because if I give you a question for 50 questions to answer in 2 hours, and I give you that same 50 questions for 4 hours, you are not going to end up having the same results. The results will differ drastic. There will be a wide range of difference in your result because of that time, the time factor. So I'm talking about time. Remember, the essence of this channel is to help you to solve very difficult questions using very simple, easy, fast, and accurate steps. So I'm saying here that if I'm giving a problem in this case, I'm told that the platinum, you have to watch out for the concentration, watch out for position, and watch out for the nature of the electrode. These three things are very, very vital. The concentration factor will cancel the effect of the position in the electrochemical series if the distance is small. You understand? And the nature of the electrode can also cancel the product at the anode and the cathode if in spite of the position and in spite of the concentration. Yes, so you have to look out for something that you have to always look out for when you are solving problem in electrolysis is the nature of the electrode. So here we are told. So let's go back to this question that we have at hand. So we see we are talking about at the anode. We said that anode electrolysis, oxidation takes place at the anode. So if oxidation takes place, who is going to be discharged in preference? This and this, according to our electrochemical series, OH will be discharged. So we have something like this for OH minus to give me, these are standard reactions, standard reactions. These are standard reactions. So this is what happens at the anode. Each time OH is discharged, we have a molecule of water. I think 2 molecules of water. Let's see if the equation is balanced. This is 4, this is 4. Yes, and this 4, this is 2, this is 2. Good. So this is what happens at the anode. Each time OH is discharged, we always have 2 molecules of water, 1 molecule of oxygen, and as well as 4 electrons, being lost. So at the anode, this is what will be happening at the anode. So this is the expected reaction that is taking place, you understand, at the anode. Remember what I said, that you have to look out for there are things that are worthy of note whenever you are doing electrolysis. First is, am I doing electrolysis of a molten compound, or am I doing electrolysis of a solution of a compound? If it's molten, then I have just 2 ions, 1 cation and 1 anion. And then if I'm doing electrolysis of a solution of a compound, I have 4 ions, 2 cations and 2 anions. Then remember what I said, that at the anode oxidation takes place, and at the cathode reduction takes place. And at the cathode is the negative electrode where which electricity leaves the electrolyte, while the anode is the positive electrode where direct current enters into the electrolyte. And remember what electrolysis is. Electrolysis is the decomposition of a compound when direct current passes through the molten compound or the solution of the compound. Please do well to like and share this video. God bless you, and bye-bye.